The first question says, suppose a perfectly competitive market is in long-run equilibrium with zero profits for all sellers, because that's what it takes to be a long-run equilibrium in a perfectly competitive market. Okay. There's no restrictions on entry or exit by the sellers. Demand is downward sloping. It's good. And the short-run supply curve at any point is upward sloping. Okay, so that just says demand slopes down, supply slopes up, as they typically do. If demand decreases, then what happens? So let's take a little sketch here. If we are in a place where this is our market, and originally this is the market amount produced and sold. If we were to look at an individual firm, right, so these individual firms also have some marginal cost curve. However, the market price says how much they sell for and how many they sell. So there's the amount that an individual firm would sell. It's supposed to be a lowercase q. Anyways, so now our demand curve is decreasing. So in the market, we see demand shift inward like this. Oh, I forgot something in our firm. So also because this is the long-run equilibrium, it must be the case that right here is where our average total cost curve, and somewhere down here is our average variable cost. Okay, back to the market. So demand is decreasing. That means the price is going to fall. We don't know how much, but the price is going to fall. So if it's going before this P0, which is your zero profit price, if you're going below the zero profit price, you must be in a place of negative profits or losses, as some call them, because the price went down. So we're looking for something that says the price is going to decrease. So it can't be this one or that one because our price is decreasing. Okay. And then the next part is to figure out what's going to happen. Are people going to enter, exit, or stay? Well, it depends on how far demand goes down as to how quickly people exit, but because there's losses, be it now or at some point in the future where they can renegotiate, you'll see that they do want to close. And so there's going to cause the supply to fall eventually because people will exit. And the one that has the description of people exiting is this top one, right? They're going to exit. They're not going to do nothing, and they're not going to want to enter in these losses. They're going to want to exit. So you may not have needed a picture to figure all that out. Sketching one to figure out that the price is going down, but that's your same picture you've been drawing in general. And when the price is lower than the zero profit price, that means there's losses and people leave. So either way could work to reason through this one. Here we have a table of the costs to run a pizza parlor per day based on how many workers you have, and it tells us that pizza sells for $10 each. The question says when there's 3 workers, how much is their profit? So I'm going to create a column here for their total revenue. I only need it for this one for now. In the future, we're going to need it for all of them. And the total costs, and then that'll help us calculate profit. So we're just going to do this one for now. So 3 workers, they're making 150 pizzas per day. At $10 a pizza, that's $1,500. So you just take the price times the quantity. Then to get the total cost, you add the fixed cost and the variable costs. So that's 500 and 450 to get 950. And then the profit is just the difference between the two. So 1,500 minus 950 is 550. And that's a positive number, so it is a profit of 550 if they choose to use 3 workers. So this is the same chart we had in the previous one. Pizzas are still $10 each, but we're supposed to figure out how many workers they should hire to come in and work based on the price of a pizza. So to do that, normally we would find marginal cost and set that equal to the price. The problem is that marginal cost should be a per unit of output, so per pizza, but we are given our numbers in per workers, which is more than one pizza. And in fact, it's a varying amount of pizza. So to keep things easier, instead of doing our normal method, we are going to find the total revenue, the total cost, and the profit, just like I was sort of starting to do in the last one. So let's fill in all of these here. Okay, so total revenue is $10 because that's the price, times the number of pizzas. So if you have 0 workers, you have 0 pizzas, so you make 0 money. If you have 1 worker, you have 25 pizzas, so you get $250. And I'm just taking these pizzas per day and multiplying it times 10 to get how much revenue. And then at 2 workers, that's 75 times 10, so 750. We already found 3 workers, 1,500, 2,000, 2,050. Okay. And then our total cost is our sum of the 2 types of cost, the fixed and the variable. So for our first one, that is going to be 500 plus 0, so that's 500, and 500 plus 200, 700, 500 plus 350, 850, 500 plus 450, 950, 500 plus 600, 1100, 500 plus 800, 1300, and that gives us our costs. So our profit is our total revenue minus our total costs. So our first one is 0 minus 500. That gives us a negative 500. 250 minus 700 gives us a negative 450. So better than the last one, but still not great. Then 750 minus 850 is negative 100. Again better, still not good. 1500 minus 950 is 550, but a positive number now, so they're making profits. 2,000 minus 1,100 is 900, and 2,050 minus 1,300 is 750. So, if the goal is to maximize profits, we look for our highest profit, which is here, $900. Trace that back, and we see that corresponds to 4 workers. So they should have 4 workers to answer the first question. How many pizzas would they make? 4 workers make 200 pizzas. And then what is the daily profit? That was that number we just calculated. So they would have $900 in profit per day. This question gives you a lot of different numbers, but let's look and see what we're supposed to be calculating. We're looking for average variable cost. So average variable cost is variable cost divided by output. So we need to look for our variable costs, which it tells us up here is 1,500. And then we need to look for the number of units, which is 500. So that's 1,500 divided by 500. It's dollars per Q. So that comes to $3. So the average variable cost is $3. Right, it gave you some extra numbers in there, so it's a good idea to make sure you know what you're looking for when you're calculating it. This question is going to be a multi-part question. So let's read our scenario at the beginning and answer the first part first. Suppose a perfectly competitive firm can produce 10,000 bushels of corn a year at an output at which marginal cost equals marginal revenue. That means they're doing the best they can do given the price. So their option is 10,000 bushels or to close their doors, is essentially what that sentence is saying. It tells us also that the market price of corn is $2 per bushel. The firm's total costs are $30,000 and fixed costs are $15,000. What should they do? Well, we know what their marginal revenue is because it's the same as the price. It's $2. That's what they get. So let's see what the average total cost and the average variable costs look like. because that'll help us figure out whether we're in that top region making profits, that middle region making losses but wanting to stay open, or that bottom region where we want to close. So I'm referring to the cost curve regions that are more graphically drawn in the notes in the previous video. So take a look back at that if you need a refresher. So average total cost is total cost divided by Q. It tells us that their total costs are 30,000. So that's 30,000 divided by their output, which is 10,000 bushels. 30,000 divided by 10,000 is 3. Average variable cost is going to be the variable cost divided by Q. We don't have the variable cost, but we do know that fixed costs are 15,000. Since total costs are variable costs plus fixed costs, and we know the total costs are 30,000, the variable costs are what we want to find, and the fixed costs are 15,000. If we solve for the variable cost, subtracting 15,000 from both sides, we get 30 minus 15,000, which is 15,000. So the variable cost is 15,000 as well, at least for 10,000 bushels. So then we divide 15,000 by 10 and get $1.50. So let's look at what's going on. So our price of $2 is less than their average total cost. That means in total, including their fixed cost, it costs them $3 to produce a bushel of corn, and they can only sell it for $2. So that means they are at a place where they're making losses, right? It costs more to produce in total than they can sell it for. So let's look at the average variable cost. So they can sell it for $2, and the variable resources like people and water and whatever else it is to do it, those are only $1.50, so the price can cover the variable costs. So that means they're not literally losing money to go out and pick corn that's already been grown. If the price was low enough, then they might be. But because they're able to pay their workers and whatever else it is they need, like water, to finish growing the crops, they're going to want to stay open, at least for a little while. Right? So they'll pick this year's crops. They just might not plant corn for next year. Might want to look at some other crops to produce. So increasing production is not a good option. So A is not a good option because then you would be at a place where your marginal cost is greater than your marginal revenue, so you don't want to do that. That's why I started out by saying their options really are to produce 10,000 or to shut down. Those are really the only two things that make sense. B says produce 10,000 because though they're losing money, they would lose less than if they shut down, and that is true. And that's because they can cover all of their variable costs, and they have a 50 cents per bushel to go towards paying like their leasing of equipment or their mortgage on the farmland, whatever it is. So they do not want to shut down, and the price may or may not increase, but that's not what makes them want to continue to produce. So they're going to be left with producing 10,000 bushels. So we're still looking at that firm that's producing but at a loss because they can't cover their total costs, but they can cover more than their variable costs. And this asks, what happens if the price were to increase to $4? So say demand for corn went up because of ethanol, maybe, and so people are willing to pay more for a bushel of corn. That makes the price they can sell it for rise. So this essentially, if we're looking at the firm, they're in a scenario where their current price of $2 is somewhere here maybe, and they produced 10,000 bushels. So it looks something like this. So now we're saying their price is going up. I don't know how much, but it's going up to $4. It could be that they're still at a loss. It could be that it's enough they're up here. Either way, we can clearly say that they're going to want to produce more corn. So this one is not looking for anything super in depth, just the fact that when the price or the marginal revenue or the marginal benefit, whatever you want to think of it as, rises, they're going to produce more of it. They could be still producing at a loss. They could be making profits now. There's not enough information just yet to be able to make that call. All we can say is because they were willing to produce at $2, they're definitely going to be willing to produce at $4, and they're going to want to produce some more corn than they did at $2. It's the only things we can say for certain. So I had to add some more information than what's in the sample questions. So the sample question has the first part and then that part 3 question. It does not have this little blurb here in the middle, but that is crucial to being able to answer the question. So you need this piece. If you're wondering how I got an answer like I'm about to get, it's because this has been added here. It was not in the Word document when you downloaded it. So be sure to add it in there so that you can see what's going on. So we've still got our company making corn. And now we have a little more information about what's happening. At a price of $4, they want to produce 20,000 bushels. Right? We said they should want to produce more, and they do. And 20,000 is where marginal cost equals marginal revenue. That's good. The firm's total cost would increase to 40,000. Okay. So now we can figure out what the average total cost is. So they're making $40,000, or it costs them $40,000 to make 20,000 bushels. So that is an average total cost of $2. Our price is now $4. So now we're in a place where our costs are lower than our price. This means it costs on average $2 to make them, and they can sell them for $4. So if that's the case, they now have profits. So they're going to want to stay open, but also because there's profits, when we're talking about the long run, these profits are going to attract new firms. So that means next year more people are going to want to plant corn because you're making $2 a bushel on them, right? Because the difference between $4 the price and $2 the cost is 2. So you're making $2 a bushel per corn above your actual accounting profit and economic profit. So that's going to make new people want to enter, and by attracting entrants, that makes the supply curve rise, and so the price is going to go down. Not back down to $2 like it was in the first part of the question, but it's going to go down a little bit, somewhere between 4 and 2, wherever that zero profit price is. So we can say for certain that profits are going to be happening, so a firm is going to want to stay open. In fact, it's going to be so attractive that new people are going to want to come and do it, and that makes the supply curve rise, which makes the price for the product fall. So this question asking, when will a firm make losses but continue to produce despite this? So we need to look at our 2 special places, which are the 2 places where average total cost and average variable cost intersect marginal cost. So this is our first one here at P3. And at P3 is special because above it, people make profits. Because above it, the price is going to be higher than the average total cost. And below it, people make losses. Okay. And then our next important point is going to be here at P2. So at P2, above it, you're going to want to stay open, because even if you have losses, you're better off than closing. And below it, you're going to close. So when do you make loss but still produce? This range between the 2, right? So losses and stay open is in this area. So that's between P2 and P3, which is right here. So instead of looking at all the options and get mixed up, I recommend going to your graph, finding those 2 critical points, which are the minimum of where average total cost and average variable cost intersect marginal cost. And then look back and see which ones are the ones you want. This question is asking about a firm's long-run shutdown criteria. I don't fully love how the rest of these are worded, so let's do what we can. So first off, in the long run, there are no fixed costs. So this one doesn't even make sense to ask because there's no such thing as fixed costs. In fact, total costs are the same thing as average variable cost. Okay? And so our shutdown criteria has to do with the price and how it relates to our costs, not average revenue. We're looking at price. Okay, so we've got it down to a couple. And technically, because variable and total are the same thing, we could just change that word to total, and we're looking at that. So the question is, do we want to shut down if our price is above the average variable cost, total cost, equal to the total cost, or below it? So above, at, or below. And if we were to sketch our graph, we've got marginal cost, average total cost. This is our point of profit, or of zero profit, and above it you're going to be open, and below it you're going to close. So we want, in order to shut down, the price would need to be below the average total cost, which is the same as variable cost. So it's B. All right, so now we need to figure out which of the following costs does not vary with the amount of output a firm produces. So our options are marginal cost, average fixed costs, total fixed costs. Those are just fixed costs, excuse me. Fixed costs, average fixed popping up again. And okay, it's just combinations of those things. So we got to figure out what's changing. So fixed cost is just a number. So no matter what, it is that same number, whether you make none, 10, or 1,000. So fixed cost does not change. Oh, marking through it was the wrong idea. So it stays the same. Average fixed cost is fixed cost divided by Q. So even though fixed costs aren't changing, the Q is changing as you do more. So this is going to change. In fact, it gets smaller as Q increases. Marginal cost increases as we produce more. Okay, that's what our picture says. So it does change. So the only thing that stays the same, that does not vary, is fixed costs. The others do change.